All right, let's talk about something you're probably using right now to watch this, a computer. We're going to pop the hood, so to speak, and really figure out what this machine that changed everything is all about. Let's get into it.
I mean, really think about it for a second. You click a button, and this whole world just appears. A whole universe of information, games, communication. But what is actually happening inside that box on your desk or that little phone in your pocket? What's the secret sauce?
Okay, so when you boil it all down, it's actually pretty straightforward. A computer is basically an electronic device that takes in data, just raw stuff, and follows a set of instructions to turn it into something meaningful. And that's the key right there. It doesn't think, it just follows orders. But it does it with mind-blowing speed.
So how does it pull that off? Well, believe it or not, every single computer out there, I'm talking from the giant supercomputers that predict the weather all the way down to your smartphone, they all follow the exact same basic recipe. It's a simple 4-step process.
And this cycle is everything. First up, you've got input. That's just getting data in, typing on your keyboard or clicking your mouse. Next, you have processing. This is where the computer's brain kicks in and does the heavy lifting. Then comes the output. That's the result you actually see or hear, like text on the screen. And finally, you have storage, which is just saving everything for later. So it's input, process, output, store. Over and over and over again. It's a constant loop.
Okay, let's make this super simple. Think about playing a song on your phone. When you tap the play button, that's your input. The phone's little brain finding that song file and getting it ready to play, that's processing. The music blasting out of your headphones, that's the output. And the song file itself, just sitting there on your drive, ready for you to listen to it again tomorrow? Yep, that's storage. See? It's happening all the time.
Okay, so who's actually doing all of this work? Well, every computer is basically a team of two. You have the hardware and the software, and they have to work together perfectly. The easiest way to think about it is like a body and a soul. The hardware is all the physical stuff you can actually touch. Your screen, your mouse, the wires, the chips inside, that's the body. But, a body without a brain doesn't do much, right? That's where the software comes in. It's the set of instructions, the code, the programs. It's the soul that tells the body exactly what to do. And if you look at the different pieces of hardware, you can see how they map right back to those 4 functions we just talked about. Your keyboard and mouse, they're your input devices. The monitor, the speakers, a printer, all output. The hard drive or the SSD, that's your storage. And that really, really important chip, the CPU, that handles all the processing. Now, when it comes to software, there are kind of 2 layers. First, you've got the system software. Think Windows or macOS or Linux. This is the foundation of the house. It's the operating system that runs the whole show and manages all the hardware. On top of that foundation, you have application software. These are the tools you actually use, like your web browser, Photoshop, or your favorite game. They're the furniture and appliances inside the house. Okay, I just mentioned the CPU. Let's pause on that for a second because this is where the real action happens. We need to zoom in and take a closer look at what is, without a doubt, the single most important piece of hardware in the entire system. People call it the brain of the computer, and honestly, that's not just a cute nickname. It's the perfect way to describe it. The CPU, the central processing unit, is literally where all the calculations and logical decisions get made. It is the master controller of the whole operation. But here's a cool little detail. The CPU isn't just one single thing. It's more like a tiny little team working together at incredible speeds. You've got the ALU, that's the math genius of the group, crunching all the numbers. Then you've got the CU, the control unit, which is like the traffic cop, directing where all the data goes. And then you have these things called registers. Think of them as tiny, super fast sticky notes for holding little bits of info the CPU needs right this second. Of course, this brain needs a place to work, right? And that's where memory comes in. The workbench analogy is seriously the best way to get it. Think of RAM as your temporary workbench. It's where you put everything you're currently working on. It's super fast to access, but when you're done for the day and turn off the power, the workbench gets cleared. Your hard drive, on the other hand, is the big filing cabinet in the corner. That's for long-term storage, keeping all your files safe and sound even when the power is off.
So, okay, we've got hardware, software, a brain, a workbench, and a filing cabinet. These are the building blocks. And these same core ideas apply to every single computer, which is wild when you think about it. Because, as we all know, computers come in a ton of different shapes and sizes. Let's kind of zoom out and look at the whole family tree. I mean, look at this range. It's incredible. On one end of the spectrum, you have these massive supercomputers that can take up an entire room, doing crazy complex stuff like forecasting hurricanes. Then, on the complete opposite end, you have tiny little embedded computers, the brains hidden inside your car or an ATM, each one built to do just one specific thing. And then right in the middle, that's us. That's where you find the microcomputers we all know and love, our desktops, our laptops, our tablets. So you have to ask, right? What is it about these machines? How did they manage to totally run our world in just a few decades? Well, it really boils down to a handful of key characteristics. Or maybe a better word is superpowers. And here they are. First, speed. We're talking millions, even billions of calculations per second. It's just staggering. Then there's accuracy. They just don't make mistakes like we do. You also have diligence. A computer can do the most boring, repetitive task a million times in a row and never get tired, never lose focus. They're also incredibly versatile. The same machine can be used for editing movies or for balancing a budget. And finally, storage. Their ability to remember massive, massive amounts of data is a true game changer. And it's because of those superpowers that they are now the backbone of, well, pretty much everything. You name it. Education, business, healthcare, entertainment, how we talk to each other. It's all powered by computers. They're woven into the very fabric of our lives. But if you had to boil it all down to one single idea, this is it. The computer's greatest strength is its ability to follow our orders with incredible speed and perfect reliability. But that's also its biggest limitation. It's not actually smart. It can't think for itself. It can't have a new idea or feel an emotion. It can only, and I mean only, do exactly what we tell it to do. And that kind of leaves us with this one last big idea to chew on. Computers follow our instructions perfectly, but what happens when our instructions are wrong? Their power is just a mirror reflecting our own commands back at us. So maybe the most important question isn't what can a computer do, but how well can we tell it what to do? Something to think about. Thanks for joining me.